Alright, so in this video we're going to look at setting up an environment to do geospatial deep learning using Python. Alright, so here we're going to look at, first off, just kind of the key libraries that are important for data science in Python, working with geospatial data in Python, and then lastly doing deep learning using PyTorch. Okay, so when you're going to do deep learning, data science, geospatial data science, in Python, you're going to need to have a set of libraries installed. And this can be a little tricky sometimes because sometimes there can be issues with things being version specific and whatnot. So to start off with, pretty much all machine learning environments or deep learning or data science environments, you're going to need to use, you're going to need to have NumPy available. This allows for like matrix algebra and working with data arrays. Tensors were effectively created on top of this model. So that's a requirement if you're going to do any type of data science. You have to have NumPy. Another really useful package or library to have installed is Pandas. If you're an R user and you're familiar with working with data frames, Pandas is similar in that it allows you to create data frames in Python and work with data tables. So if you've worked even with like Excel spreadsheets where you have columns with different data types, that's effectively what like a Pandas data frame is. So both of those are really key. Pretty much all graphing or data visualization is built on top of matplotlib. So here's the website for matplotlib. So if you are a MATLAB user, this graphing environment is kind of based on the graphing in MATLAB. So anyway, that's where this comes from. So that's matplotlib. Seaborn is another graphing library that sits on top of matplotlib and makes some things easier. So I generally install that too. Okay, so and then the other key tools for just general data science is SciPy, which is basically scientific computing in Python, and it has a bunch of different plugins and whatnot to do specific things. So, for example, scikit-learn is used for like machine learning and predictive modeling using SciPy and Python. So you can do things like support vector machines or random forest or regression or classification problems. And some of the tools in here are implemented for things like training and test data partitioning and whatnot, even for deep learning. So these are all the key libraries for data science. So now let's look at a couple of the libraries that are really important if you're going to work with spatial data. Okay, so if you're going to work with vector spatial data, generally you want to install Geopandas. Geopandas basically extends pandas to allow for reading not just tables, but tables with spatial information, so point, line, and polygons. And it also has a bunch of dependencies. You need to make sure get installed correctly. So let's look at that real quick. So it relies on NumPy and Pandas, Shapely, which allows it to interface with geos, Fiona for interfacing with GDAL, and PyProj for interfacing with Proj. So all those are required, and then there's some other optionals: Rtree for spatial indexing, GeoPy for geocoding, and also you see Matplotlib and MapClassify. Generally, I find that these install when you install Geopandas, and you don't have to do it like manually. But if you do have an issue, you should look back here and see if you're missing some dependencies. Okay, so that generally covers you for reading in vector data. If you're going to work with raster data, then you need to install Rasterio, which is this package here. So Rasterio, again, allows for you to work with raster geospatial data layers that interface as well with GDAL for doing data transformations. So that's another important environment. Okay, so those are the key, again, data science in general, and then a couple geospatial specific libraries. Now, for this, we're looking at setting up an environment to do deep learning specifically, and then be more specifically doing deep learning with PyTorch. Okay, so going to the PyTorch page here, you can see what we have in terms of requirements. So they have this nifty little graph here, so you can pick the version you want. So you can do the stable version, the nightly, which is kind of a little more experimental version. So I'm just going to use stable. You can pick your operating system. I'm on a Windows machine. The package manager that you're using, so I'm just put Conda there. And then we want our Python as opposed to JavaScript or C++. And then your CUDA version, so just you can pick 10.2 or 11.1, and then it shows you what command you need to run to actually set that up. So here it would install PyTorch, Torch Vision, Torch Audio, the CUDA Toolkit 10.2, and then from the PyTorch channel there specifically. Okay, so you definitely have to install that. To make this process a little easier, generally we want to install some other libraries. So for example, with one common task is to do data transformations or data augmentations to try to create more training data, more variability, or try to reduce overfitting. There are tools for doing that built into Torch Vision, which will get installed here, as you can see. But I really like this other library called Augmentations, which I just think is a lot easier to use. It's pretty, I don't know, it's pretty fluid. So anyway, I would recommend installing Augmentations as a tool for doing your data augmentations and whatnot. It's also good to have OpenCV installed. It's a computer vision library. For example, you can use this library to like read in image files, transform image files, save things out to disk, stuff like that. Okay, and then lastly, we want to perform, if you're interested in performing semantic segmentation or pixel level classification tasks, you could work in PyTorch just natively, but that's actually pretty complicated. You have to build all the models from scratch. Again, it's complicated. So I recommend using this segmentation models library. Note there's two versions of this. There's one for Keras and there's one for PyTorch. So this is the PyTorch version, and this makes it a lot easier to implement some common semantic segmentation models and then do model assessment, predicting the new data. So example models that are included here are UNet, UNet++, DeepLab, V3+. So we're gonna use this in the course because it just makes it a lot easier to apply these models to new data. All right, so if you're going to install Python for data science, you can just install Python kind of on its own. But generally, if you're going to do data science and specifically if you're going to work on a Windows machine, it's generally just easiest to install Python with Anaconda. Currently, the single-use license for this is free, so this is free software. So we're going to look at, so I'm just on the Anaconda page here. I'm going to go to Products, Individual Edition, and then we can see what options we have. So for example here, we have a download for Windows, which should work. So I don't need to download this because I already have, but I'm just going to try to step through this process so you can kind of see how this works. So we hit Save File here. That's going to start the download. Alright, so now let's open up this download, and you can see here we've got an exe file, so let me open that, and this just started an installation process. Now I'm not going to run through this whole process I already have installed, but I just wanted to show you a few things. Alright, so if we click next here, and agree to the licensing there, just for me for now, you'll pick a folder to install to. Oh, that already exists, so I guess I can't proceed. But anyway, in the next, let me see this make something up. Let me see if it'll let me do that. There we go. So one thing that you want to do is you want to do this add Anaconda 3 to my path environment variable. I mean, actually, it doesn't want you to do that, but it makes it easier when things are on path. So you definitely want to do that for data science. And if you click install, it'll run the install process. So I'm not going to do this because I already have it installed, so I'm just going to quick exit setup there, and let's look at what this looks like when we actually have it installed. Okay, so down here in my list of programs, I'm going to this Anaconda folder, and then there you can see we have Anaconda Navigator, the PowerShell prompt, the command line prompt, Jupyter Notebook, and Spider, which is an IDE for Python. Right, so if you're going to do deep learning on your machine, you're probably going to need to set up and have access to a decent GPU. Without that, it can be pretty slow, especially if you're relying on convolutional neural networks, which is primarily what we're going to look at here. So right now, what that means is you need to have a CUDA-enabled NVIDIA graphics card. So for example, in this machine, I have NVIDIA RTX 2080 Ti graphics card, which is capable of doing this type of computation. Okay, so if you have a machine that meets that criteria, then you can install the CUDA toolkit and some other libraries to do some deep learning with. Okay, so to do that, you want to make sure you're using the correct version, and that kind of depends on what type of environment you're setting up. So I'm just going to go back to the PyTorch page here and just look at the recommendations. So you can see here it has CUDA 10.2 and CUDA 11.1. So let's say we're just going to use 10.2, and again, you might need to experiment and figure out which of these environments works best on your setup. So anyway, I just did a CUDA 10.2 install, and I found this NVIDIA developers page here. And I'm on a Windows machine. I'm on a Windows 10 machine. And we want to do this one here. And then you can do the base installer, and that's going to download and install that. So I'm not going to go through that process I already have. It's pretty simple. Note that if you are on a Windows machine, it's going to need access to Visual Basic Studio, and it'll install that. And if you don't have the right version or something, you may have to install that, but you should be able to get a free version, so that shouldn't be an issue. Okay, so once you have that installed, you're going to get a folder in your program files, which is... Let's see here, NVIDIA GPU Computing Toolkit, and that's CUDA. And you can see I have a couple different versions here. So I've already installed 10.2, and I have 11.1 and 11.2. And as you can see on the PyTorch page, which is here, there isn't a 11.2 listed, so you probably don't want to install that. There might be compatibility issues. I would probably try 11.1 first, and if that's not working, you could always try 10.2. But it's supposed to work with both of these. Okay, so once you have CUDA set up, that's not enough. You also have to install this CUDNN library. So let me go back to this. So I just searched for CUDNN download, and I went to this archive page. Now, note you can't just go to this page. You have to sign up for an NVIDIA account. It's free, so it's safe. So if you need to download this, you just need to sign up for an account. Okay, and then the next thing you need to do is download the CUDA or CUDNN that works with the version of CUDA you have. So for example, here we can see there's this one for 10.2. Another one for 10.2. So if I wanted this one, click on it there. We're on a Windows 10 machine. Download that. And that's going. Again, you may have to play with this a bit if you set it up and it's not working. You may need to try a different version. It can be a little tricky. Okay, so that just downloaded. So now I'm going to extract that out. All right, so now we have our folder here, and inside of here we have this bin folder, which has some files in there. We have this include folder and this lib folder, and then 64, and then some extensions. So what do you actually do with these? So what you actually have to do is manually move these into that CUDA environment in your program files. So I'm just going to go to that location. So C, program files, CUDA, which is where we are, NVIDIA GPU Computing Toolkit, and CUDA, and then the version, so 10.2, and then you just want to move the files into the associated folder. So, for example, the bin files go in the bin folder, right? And the include goes in include, lib goes in lib, right? I already did this, so if we go into bin here, we can see that I have this, let's see, where is it? There's CUDA DNN 64_7. That was the version of that I moved over. This might be a different version. Let me see. This is 8, so I had to move that over. I didn't move these over, and it didn't seem to matter. But I think if you do move them, it won't break anything. So you just need to move things into its associated folder. So they include to include, lib to lib64 to lib64, and then bin to bin. And then that should allow you to use CUDA on your machine. Now, to make sure you have access to a GPU to use PyTorch, let me just show you a way to test that. I'm just going to open up RStudio here. Okay. All right. So again, we're going to activate an environment. We'll talk about how to do this later. Here we're just doing this for test. So I have a PyTorch environment set up. So I'm going to activate that, and then I'm going to open up a file that has let's see, some code in it that I can test. And let's see here. And let's just grab this train file. Okay, so let me run up to the top of this. Again, these are just importing some libraries. Run that real quick. Okay, so once these libraries are imported, this is code that comes from PyTorch. So this avail torch.cuda is available. If you run that method, I guess it's function. Let me just run all of these actually. So this will tell you what true or false whether or not it's finding a GPU. This tells you the number of GPUs. So it should just be one on my machine, and then the name of each device, and it's indexed at 0. So this is the first GPU, and I'm just printing that information. Okay, so you can see there available is true, so that means it found my GPU. Count as 1. I have 1 GPU, and the name of that GPU is this GeForce RTX 2080 Ti. Okay, so generally if that works, that means that Torch can see your GPU, so you should be able to use it in your computation. Okay, so once you have Anaconda set up, if you go into that program and your program list here, there's a couple different tools here that you can access. I'm going to access the command line using the PowerShell. You can also just use the regular command prompt. I'm just going to use PowerShell because I like it. Okay, so anyway, this basically just loads the cursor here, and you can see that it's setting in the base environment. Now, you should never really install libraries, packages into the base environment. What you want to do is set up sandboxes or new environments for different tasks. So I already have an environment set up for deep learning here, but I'm just going to step you through how you would create a new base or a new environment. So to do that, you just do conda create. And then you have to give it a name. So let me do that. Name. And then the name that you want to provide, I'm just going to call this example env. And you can also specify a version of Python. If you don't, it's going to use whatever the default version is that installed when you set up Anaconda, which I believe I'm on 3.8. Okay, so let's hit enter there. And then this should go through and create that environment. Okay, and this is telling us where we're going to install it. You can move it someplace else if you want, but we don't need to. Hit yes there, and then we're done. Okay, so that just created an environment. If you want to see the list of environments, you can do conda environment and then list, and that should list out all your environments. Okay, so these are the environments I have on my machine. So I have the base environment. Again, you really shouldn't install into that. I have the one I just made with the example env, and then I have this PyTorch environment, which is the one I set up for PyTorch. Note there are a few others here, and these are actually coming from other locations kind of outside of Anaconda. As you can see here, it's under app data as opposed to Anaconda. So basically these two are from my ArcGIS Pro, which installs with Python. You can set up environments, and these came from Reticulate, which is I guess from Anaconda, which was set up when I installed Reticulate package in R for running Python in R. It's basically these first three that were associated with Anaconda. Okay, if you want to know where those go, again, you can just go to that path there. So, for example, here, let's go to that location, and then we have, let's see here, Anaconda 3, and then your environments are going to show up here. Okay, all right, so let's look at activating an environment now. So to activate an environment, we just do conda activate, and then the environment name. So I'm going to do my one I just made, example env. Okay, and now you can see this name changed. So now we have example env as opposed to base, right? So now we're in this new environment. Once you're in an environment, you can list all of the libraries, packages that are installed there, and that's just simply done with conda, I believe it's just conda list. Yeah, so you can see here there's nothing because it's new. So to install a library, I'm just going to install something simple. Let's do NumPy first. So you can do that with conda. You could do it with pip. Let's see. Let's just go to the NumPy page and see what it suggests. Okay, so let's see here. Install. So there's pip option. There's conda. You can do it with conda forge channel. Let's just do conda install NumPy. And we'll dump this in here. And that should set that up for us. Okay, and then it's going to install some other dependencies. So we'll hit yes there. And it's going to go through and do that installation. Okay, so that's effectively how you go through and install a package. So now if we do conda list, it should have those new packages listed in that environment. Okay, so let's switch over to my PyTorch environment. So I'm going to do a conda deactivate now. And that puts us back in the base environment. And then we want to go into my PyTorch environment. So we're going to do conda activate PyTorch SB, which is PyTorch Sandbox. Oop. Active. Oops. There we go. Activate. Okay, now we're in that environment. So if we wanted to see what's in this environment, then I can do conda, again, list, and that'll list all the packages. Okay, so you can see this here. This is all the packages that are in here. It's a pretty big list. You can see also the version, the build, and then how it was installed. So if it was installed with pip, you can see I mainly use the conda force channel here, but I did some with PyPy or pip and as opposed to conda. Right, so if you want to use our environment that we set up in the GitHub repo under utilities, there should be this environment.yaml file. And again, that's what you would download and run in order to clone out the environment. We also have this file here, which was which steps you kind of through that process at the command line. All right, so so I have this environment already set up, and I've been using it, so I know that it's working correctly and everything. So what I would like to do is create an easy way to basically clone this environment either on this machine or on a completely different machine. Okay, so to clone an environment, it's pretty easy. You just do conda, oh, sorry, let me grab this here, conda env export, and then I'm just going to call it my env.yml, which is a YAML file. Okay, so what that should do then is make a YAML file that we can use to replicate this environment. Okay, so it kicked back to the cursor there. So now if I go to this location on my drive, I should have that file. So we pull this over here. we have this my env YAML. So I'm just going to open this up in like Notepad so you can see it. So you can see here it lists out the name of the environment, the channels that I use to download all the packages, all of the package dependencies or libraries that are installed, and then this is the location of the environment on my local machine. Okay, I'm just going to make one quick change for me here. I'm just going to add a 2 to the end. I don't want to overwrite my current environment, so I'm just putting a 2 there so it gives it a new name. And I probably want to do the same thing down here. Save. Okay, so now we have that file, we should be able to create an environment using it as kind of like a template. So first thing I want to do is get out of my current environment. So I'm going to do conda deactivate PyTorch sandbox, and then we're back to the base environment. Okay, and then I want to do conda create and then the file. So I just want to do my env.yaml. And since it's saved in like my home directory, I don't need to set a path or anything or change the working directory. And see what happens. All right, so let's hit enter there and see what happens. Target prefix is the base prefix. Oops. I forgot to put create in there. Conda env create. There we go. So conda environment create, and then based on this file, let's see what happens. Okay, so I'm probably just going to cut this here because this is going to take a while because there's lots of libraries that it needs to install. But we'll come back when it's done and just have a look at what it created. Okay, so this went through and executed. It took about 5 or 10 minutes. So let's see if it actually worked. So we're going to do conda activate, and we're going to activate this new environment. So we're going to do PyTorch sandbox 2. And now we're in that environment. Now I'm just going to do conda list and see what we have in terms of packages. Okay, and there you can see those are all the packages. So it looks like they were installed correctly. It looks like we have pretty much everything we need. So hopefully we should have a working environment here. So I'm going to do conda deactivate PyTorch sandbox 2. Generally good to deactivate your environments when you're done. Okay, so now we have an Anaconda environment set up. Let's make sure we can activate it or use it inside of RStudio. So we're going to do most of our work in this class in RStudio. RStudio is an IDE or integrated development environment for R, but you can also use it to run Python code. Note that you're going to need to install the reticulate package, which allows you to interface with Python. Okay, so in order to actually connect to a specific environment, first you'll need to activate the reticulate package. So that's what this line is doing. And then you can use this use Python function to link to a specific environment. And note you're going to link to the specific Python exe file in that environment. So I'm going to switch this to Python torch sb2 and run that. And then we'll just view that with pyconfig, and there's no arguments there. There we go. So there you can see that it's set up to use our PyTorch sandbox 2 there, and it also gives us the version of NumPy that's installed and the package manager there. Okay, and then just as another test, I'm just opening up a Python file here. So I'm just going to do some imports and make sure we get our imports as we expect. Note that when you're running Python code here as opposed to R code, it switches to the 3 hashes here. So it's going through and it looks like it found all those. There we go. So it looks like it found everything. So it looks like we've got a functioning environment.